What you just saw was the phenomena of the conservation of linear momentum. This states that the initial momentum in a system is equal to the final momentum of the system. In this graphic, line A most closely represents our experiment. One ball possesses an initial velocity and collides with another that is at rest. The only difference between our experiment and the graphic is that the graphic shows a velocity of 0 for the first ball after the collision, while we do have a nearly zero velocity. Go.
Our system consisted of 3 pool balls with a negligible difference in mass. The initial momentum of the system was 0 because all of the balls were at rest. After applying a force to ball 1, it had a velocity and collided with ball 2, which was at rest. Ball 2 was given a velocity while ball 1's velocity changed to a lesser magnitude and opposite direction. Then ball 2 continued until it collided with ball 3, which was at rest. Ball 3 was then given a velocity, and ball 2 experienced a lesser velocity in the opposite direction. Ball 3 continued to roll, but finally came to rest. This verifies the conservation of momentum because the velocities of the initial and final momentums were 0, agreeing that P initial equals P final.
Take a look at these two equations that can be used to represent the conservation of momentum of a system. Pi equals Pf. This was true in our experiment because the initial velocities and the final velocities of all the balls were 0. And since momentum equals mv, the initial momentum and the final momentum were 0. Now take a look at the second equations. This can be used to solve for variables when doing a problem. When using this equation, be sure to use only 2 balls at a time and 1 collision. In our experiment, it is important to note that the kinetic energy was partially lost due to friction between the balls with each other and the surface. This means we had an elastic but not perfectly elastic